Hi, I'm Pete Zachary. I'm here to present the Salad for March 28th, Chapter 13 from the Tangled Web by Mikhail Zalewski. The title of this chapter is Content Recognition Mechanisms. Okay, so one of the main content recognition mechanisms employed by browsers is called content sniffing. Content sniffing is a mechanism employed by browsers to correctly identify the content type received from either the server or in some cases retrieved from the local disk. It was originally added to browsers to improve the user experience when confronted with unknown content types. In other words, the browser needed to identify the content type so it would understand how to present it. Each browser implemented its own proprietary algorithm to identify content in an attempt to do it better than its competitors. If one browser was able to display broken pages better than another, potentially users would flock towards that browser. The danger here is that it allowed the browser to override the content type defined by the developers of the websites. And in some cases, as we will explore a little later, this additional functionality can be detrimental to the user. Okay, so now you'll likely want to know, how could this functionality be detrimental to the user? What's the actual problem? Well, it was soon discovered that some browsers were indeed overriding the content type provided by the server. In some cases, they were getting it wrong and misinterpreting the content type as HTML in cases where it should have been plain text or text CSV. The danger here that is very real is the possibility that some scripting may exist within the content that will be executed by the browser. So, while the developer intended to host and serve up benign content type, all of a sudden his site could be used to serve active content to the browser that may possibly contain content of a malicious nature. So after realizing this, in 1999, part of the HTTP version 1.1 specification stated that content sniffing should only be used if the content type is not provided by the developer. Now, the horse was already out of the barn. Many of the browser vendors had already integrated this functionality and were not so keen on stripping it out of their browsers. So before we go any further, this is probably a good time to understand how content sniffing is implemented. If the content type were either missing or malformed, the vendor's proprietary algorithm employed by the browser would attempt to identify the content type using various approaches. They could scan the beginning of the content looking for telltale signatures. For example, some file types have what is referred to as a magic number. You'll see that if you open up a GIF file in a hex editor, it will begin with the ASCII representation of GIF 87A or GIF 89A. They might look for HTML tags. Some browsers check the entire response for any telltale signs as to what the content type should be. And then they also, as a fallback, they'll look for other clues. They can look for file extensions, strings within the path, or just about any characteristic they can hone in on. We know that it's not a very good approach to just look at the file extension. I mean, how easy can an attacker trick a browser into performing actions they might not otherwise perform by merely renaming the file with an inaccurate file extension? For example, where a user might normally click on a text file without being so concerned, if this is really an executable file just with a txt extension, things may operate differently. Just think about how easy it would be for an attacker to place a file within a publicly accessible repository with a misleading extension in order to have a user's browser execute it based upon the file extension alone. So now let's discuss how depending on how you handle various content types, the repercussions that may come out of that. This next slide illustrates the discovery of an exploit that surfaced in 2007. A GIF file containing an embedded PHP script could be used to exploit either the server or client depending upon which end was presenting the file. Shortly after this discovery, there was a follow-up that also utilized embedded JavaScript within image files to achieve the same goal. The goal being to execute malicious scripts on either the server or client when performing what was originally thought to be merely the presentation of an image file. The majority of these known vulnerabilities have since been corrected by the browser vendors. The handling of image files and image content types will be discussed in more detail in the coming slides. So we already mentioned how earlier, back in 1999, the HTTP version 1.1 specification called for limiting content sniffing to only those cases where the content type headers were not present. For example, if you downloaded a file from a website via FTP, no metadata would be present to make a content type decision, or in the rare case where the developers of the site did not define the content type. But in reality, what was found to have been implemented was for content sniffing to be performed in cases where even the slightest syntactical errors were present in the content type definitions. This had the effect of undermining the HTTP version 1.1 call for reducing the use of content sniffing. It also allowed attackers to devise additional devious methods that would result in the misidentification of content types in order to get their code executing in your browser. Okay, so in the next few slides we'll discuss some of the special content type values. Content type application octet stream is sort of a catch-all for unrecognized content types. It generally designates content type that should have no special meaning to the server or the client. This content type is treated as a binary file, and the user will likely receive a dialog prompt to save, open, or cancel. If your browser allows you to open this directly, you need to be careful that you understand the potential ramifications. A better bet might be to save the file and scan it with an AV product before allowing it to execute. The author also goes on to note that regarding application octet stream, that in his research he has found that IE, Safari, and Opera have been known to employ content sniffing on this type of content. The danger that exists is that if this active content type is misidentified as HTML, it will be presented in line within the browser. As I mentioned earlier, content type application octet stream is sort of a catch-all for application content types that can't be matched. This application octet stream type is very often used for transmitting executable files, programs, especially on the Windows platform. Unfortunately, while this is convenient, it can be a serious security hazard. In recent years, the internet has been subject to steady stream of viruses and worms that spread by sending themselves to other users through executable file attachments in email. This makes opening and running any unknown application octet stream attachments potentially dangerous. As an example, I refer to May 2000, when the I love you worm began propagating through email. It contained an attachment that the user saw as loveletterforyou.txt. This worm deployed what is now known as the old trick of using a double extension. The first extension was a VBS extension, the second was a TXT extension, but on Windows systems at the time, users would not see the VBS extension. So when they clicked on this file that they thought was a normal text file, they would execute the VB script, which would send the attachment to 50 contacts in their address book. You can fast forward now to the more current types of attacks that are very similar in nature, and use a content type PDF, application PDF, where malicious PDF files are sent via email or posted on public websites that contain embedded JavaScript and take advantage of vulnerabilities to break out of the sandbox and execute malicious code within a user's browser. This next slide is a good example of the real danger of not conforming to the developer's content type declarations. This was posted on the Core Security website and was prevalent, cross-site scripting vulnerability that was prevalent in 2010. In this example, although the content type may have already been specified, Internet Explorer particularly would sniff the content type and misidentify, allowing the PHP script to execute. So part of the problem here is that IE attempts to identify content type using sniffing and extension analysis. But now that we have so many multimedia content types, this becomes dangerous. There's more content types every year. We have additional formats. Any data that does not parse correctly may contain malicious code that is executed within the browser. So we touched on content type image a little bit earlier. We'll go into it in a little more detail here. Image files such as JPEG, GIF, PNG can contain hidden strings. When interpreted by the browser and presented, these strings can be executed as commands. This next slide illustrates what we've been talking about. It shows the header of a GIF file displayed in a hex editor, and you can see that after the magic number, approximately after the 12th byte, there's a script inserted that until recently, before browser security was improved upon, would execute within older versions of IE. Now we'll talk a little bit about defensive options web developers can use to instruct browsers not to sniff for content types. Content option no sniff is one option mentioned by the author. Unfortunately, this option has limited support and can be ignored by some browsers. Another option is using the content disposition. This declares the content as an attachment, which should result in the browser showing a dialog to open, save, or cancel. Again, it is not fail-safe. Some browsers may ignore it under certain circumstances. Most of all, it does not protect against the user clicking the open button, which will result in the opening and potential execution of the content. Another important thing to keep in mind is the effect that content directives have on sub-resources. Most content-related directives have no impact on sub-resources at load time. Examples are image, content type, script, and embedded content types. This increases the possibility that an attacker will trick your browser into misinterpreting the content type in an attempt to execute code on your system. It's also very important to be careful when opening up content that is non-HTTP content, something that you may have downloaded via FTP or some other file transfer mechanism. FTP downloads will not contain metadata and they will need to be sniffed if opened in the browser. Saved files opened using the file syntax will lack any metadata or context. Most browsers rely on the file extension in cases where you're opening up a local file, with Chrome being an exception. Another very big area of concern is character set handling. Basically, identifying the encoding of the input stream is very important. This is usually defined in the metadata, but not always. Guessing and getting it incorrect can be quite dangerous. The byte order marks refer to a digital signature at the beginning of a file which identifies the encoding method. This can be used to override the metadata declaration. IE will allow the byte order marks to trump or override any other metadata defined by the developer. I think the threats are pretty obvious when you think about it. If you think that a developer who maintains a site and ensures that all of his directives are in place, and that someone can upload a file and override the encoding type that he's declared, potentially with some malicious content involved. So to wrap this up now, we'll just talk a few minutes about the recommendations by the author on how to better protect yourself and your website from abuses in content type identification. On the server side, always append the X-Content options no sniff to all responses. Although all browsers might not utilize this, it's a good habit to get into. Same goes for defining the character set and content type parameters. It's better to declare them wherever possible. Use content disposition attachment for any files which do not need to be displayed in the browser. This way, the user will just be prompted to open, save, or cancel, as opposed to the browser trying to interpret what content type this is. When converting from different character sets, filter out unexpected characters. Avoid using content type application octet stream. Instead, use application binary to prevent possible execution within the browser. I hope you enjoyed this presentation. If you have any additional questions, you can email me via D2L or just post a message in the delivery area of D2L. Thanks. Bye.